Calculus, Chapter 1, Lesson 4. This is going to be a short video talking about decomposing functions. We looked at composing functions where we take one whole function and put it inside of or into another function for x. In decomposing functions, we were going to do the opposite of that. We're going to create two new functions, an f of x function and a g of x function, so that when we put g into f, we end up with the original function. So basically we're going backwards, and this is something that we need to do in calculus from time to time in order to create some functions that we can work with. We want to decompose these into two more simple functions, which then allow us to work with them more efficiently. So basically it's going to be like this. You're given a function, the square root of x cubed plus 1. Now we need to create two functions, an f function and a g function, so that when we put the g function into the f function, we end up with what we begin with. And there's lots of different ways to look at it. One of the easiest ways is to simply take this function here and make that the square root of x, and then whatever you see here, make that the second function. So if the f function is the square root of x, the g function is then what we have here. You have x cubed plus 1. And again, if we compose f or g with f, we take this whole g function and put it in here, we end up back here. So in this lesson, this is really all you're going to have to do. So one more example for you. F of x is the square root of x plus 1, and g of x is x cubed would be another way that we could do this, because again, if we put this g function into this function for x, then we could get and compose those, we end up with the exact same thing. So decomposing functions, you're creating two functions such that when you compose them together, you end up with the h of x function. So for this example, we have y is equal to x squared minus 5x. And we want to create, again, two functions, an f function and a g function, that when we did f composed with g of x, we end up with y. I think that's what we want. Yeah, we want y to equal f composed with g of x. So we're going to substitute the g function into the f function. So again, one of the easiest things to do would be to simply take this whole function and make that x, square root of x. And then g of x then would simply be what's underneath here, x squared minus 5x. Now when we compose the g function with the f function, this goes in for x, and we end up with this. Another example might be y equals the absolute value of 3x minus 2. So again, the easiest thing to do would be to make f of x the absolute value of x, and then g of x then would simply be 3x minus 2, and then we could substitute 3x minus 2 into here, and we'd have the absolute value of 3x minus 2. Here we have x cubed plus 1, the quantity x cubed plus 1 squared. Again, we could simply make f of x an x squared function, and then g of x will just be what we're going to put inside, will be x cubed plus 1. Then again, composing g with f, we put the g function in the f function, and we have two new functions. Now there may be other options, and you can look at some different ways to play with those, but really that's probably the easiest way to decompose functions.